Imagine walking through the Alps and stumbling upon a secret from 5,000 years ago. That's exactly what happened in 1991, when two hikers found a man perfectly preserved in ice. He became known as Ötzi the Iceman. His discovery wasn't part of some grand expedition. It was a fluke. The glacier that had held him since prehistory was melting, revealing him to the modern world. This moment was an early chilling sign that the world's ice was changing in ways not seen for millennia. Long before we had satellites, people watched glaciers with their own eyes. In the 18th and 19th centuries, Alpine villagers watched in fear as massive glaciers crept forward, swallowing farmland and threatening their homes. Then, something shifted. Those same glaciers began to pull back. Old paintings, maps, and written records all tell the same story. Glacier fronts were once hundreds of meters lower than they are today. By the late 1800s, scientists knew that glaciers were sensitive barometers of climate. But they couldn't see the big picture. It needed a way to watch all the world's glaciers, all at once over a very long time. That all changed in 1972 with the launch of the Landsat Program. For the first time, we had a systematic eye in the sky. Landsat wasn't even designed to study climate change, but over the decades, it built an incredible, continuous record. This archive now lets scientists rewind the clock and watch half a century of glacier retreat unfold. This was the dawn of global glacier monitoring from space. Today, we have an entire fleet of satellites dedicated to this mission, each with a unique superpower. Optical satellites, like Sentinel-2, act like cosmic photographers, comparing images over time to see how much a glacier has shrunk. Then there are radar satellites, like Sentinel-1, which can see through clouds and darkness. They track how fast the ice is moving. Often a glacier will start to speed up right before we can see it visibly retreating. It's like feeling a fever before the symptoms show. But we can also measure the ice getting thinner. Altimetry satellites are the ultimate measuring tapes. IceSat-2 shoots laser pulses down to Earth, measuring the ice surface elevation with unbelievable precision down to the centimeter. Meanwhile, Cryosat-2 maps these elevation changes across vast stretches of ice. And if that's not enough, we have gravimetry missions like Glaciers. These satellites don't look at the ice, they feel it. They detect tiny shifts in Earth's gravity field as ice disappears, telling us how much mass has been lost from an entire region. Each of these methods tells a part of the story. But when you put them all together, they confirm each other's findings. It's like having multiple independent witnesses to the same event. Of course, satellite data is only half the equation. To turn volume loss into mass loss, scientists have to get their boots on the ground. They drill ice cores and dig snow pits to measure the density of the ice and snow. By combining high-tech satellite data with this hands-on fieldwork, they can calculate glacier mass loss with incredible accuracy, reducing uncertainty to less than 10%. So what have we learned? The results are stark. Since the year 2000 alone, our planet has lost about 5% of its total glacier mass. This isn't just happening in one or two places. It's a global phenomenon, from the Alps to Patagonia. Even in areas where glaciers look stable in photos, the data shows they are thinning from beneath. Optical imagery, radar, altimetry, gravimetry, they all point to the same conclusion. Glaciers are losing mass, and the rate of loss is speeding up. This isn't just an abstract scientific problem. Melting glaciers have real-world consequences. All that meltwater contributes to sea level rise. It messes with the seasonal water supply for millions of people downstream who rely on it during dry months. And as glaciers retreat, they can leave behind unstable lakes that pose a risk of catastrophic outburst floods. Perhaps the most sobering fact is that this loss is on a human timescale, permanent. Ice that took centuries or even millennia to form is gone in a few decades. It's not coming back. When Ötzi the Iceman emerged from his frozen tomb, it was a coincidence. But when our satellites document this same retreat across tens of thousands of glaciers worldwide, it is not a coincidence. It's a clear, measurable response to a warming climate told in meters of thinning, gigatons of lost mass, and millimeters of sea level rise. This is how we watch the glaciers disappear. Thanks for watching.